Welcome to Programming, Logic and Design 8th edition. This is Professor Al-Zaidi and this is chapter 1. We are going to cover chapter 1, an overview of computer and programming, or computers and programming. Objective of this chapter going to be a computer system, simple program logic, the steps involved in program development cycle, the pseudocode statement and the flowchart simple using essential value to end a program, programming and user environment, and the evaluation of a programming module. But first, let us understand how computers are, designed, or the system of the computer going to be. So, what the meaning of a computer? What the definition of the computer? As in the book says, or cover, combination of all components required to process and store data using a computer. So, in other words, if I want to understand the computer, I'm going to say the computer is an electronic device that's divided into two main sections. As you can see, we have hardware and we have software. Hardware, which is the component that we physically can interact with. We can touch it, we can see it, we can work with it. Okay, these are the components of hardware. However, we have the other section, which is the software part. That include the computer instruction, the operating system telling the computer how to deal with the hardware installed on it. So we have two other sections, which is first we have program, which is instruction written by programmers, which is going to be you going to write a program. In the software part, we have two main things as well: application software and system software, or operating system. Now, operating system, we have Windows, Linux, Unix, Mac, different type of systems. Also, we have programs, which is word processing, separate sheet, payroll, inventory, games, Photoshop, PowerPoint, the one that we are using right this moment. It's an application. We have three major operations that computer hardware and software combined accomplish. We have the input, which is inputting data into the system, which is data items such as text, numbers, images, sounds have been entered by the user. You, right this moment, consider a user. The user input data through the input. We have input devices like mice or mouse or mices. We have keyboard, microphone, scanner, webcam. All of that consider an input device. Then after we have the data inside the computer, now the second item or the second operation start, which is processing, which is the calculation and algorithms and the mathematical calculation that what we call the central processing unit perform. CPU, the brain of the computer. Consider a brain of the computer. Then we have the output. Output, which is after we process the data that we inputted, we need to see it. The computer need to deliver it to us through using monitors, printers, speakers. All of that consider an output devices. The output right this moment, the resulting information that is sent to a printer or a monitor, whatever storage device maybe. A cloud-based device is accessed through the internet, which is also sending the information to a cloud base. Now, we mentioned here the storage devices. Storage devices, hard disk, USBs, CDs, DVD, cloud components, all of that is storage devices where we can store the information to be retrieved later on. Now, if we go back here, we can see we can see one main thing. We input data. Data was input. Then we have information. Okay, the information. There are difference between data and information. Data are unorganized, didn't been yet processed, is just dumb or raw materials. The information, after being processed, the final look of our data. Now we have what we call it a programming language. Programming language used to write programs, or computer instruction called program code, and writing instruction is called coding the program. We have multiple and different levels of programs or programming languages: Visual Basic, C, C++, Java. We may have different type of programming, PHP, so also consider programming for websites. We have different type of languages that we can use. However, in this course we are going to understand the basic of programming, basic of the programming. So we are not going to write something like this complicated. We are going to write using a pseudocode, which is a simple text thing that we can understand as we go through. We have what we call it a syntax, which is rules governing word usage and punctuation. A mistake in a language usage or a syntax error. We have a computer memory. The computer memory, which is we have two types of memories: storage devices, which is the permanent storage device, and we have the memory, computer memory, which is temporary interstorage, called random access memory, which is RAM. Need to have electricity, is volatile memory. The moment that we don't have electricity, everything stored on this RAM has been gone. So we have another type of memory, which is permanent storage devices, which is hard disk, SSDs, USBs, CD, DVD, multiple things that we can store our data or information on it to be retrieved later on. Compiler, or what we call it also interpreter, which is translates the source code into the machine language, or what's known as the binary language. The binary language, which is a statement called, the translation going to be the object code, and the compiler will check for errors. Let me stop over here for a while. Let me go so quickly into the binary language. A binary language is the language that the computer do understand. We have 0, we have 1. The binary language includes only two values, 0 and 1. Okay? Why? Because we have electricity, we don't have electricity. Yes, no. Violated, not violated. So 0 and 1. 0 and 1. This is the binary language. Now, each value of these known as bits. I'm going to explain it so quickly so we know how it's related to our work, especially with storage devices and also the memory. So when we have 8 of these, now what we know as bytes. When we have 1024 bytes, we will have the kilobyte. Now the question is, why is 1024? Why is not 1000? The answer is simple. Let me go here. We have 8. The 8, we have the multiplication of 8 because we have here an 8 in our byte. So we have then 16, then 32, 64, 128, 556, 256, sorry, 512, 1024. That's why we have 1024. That's why sometimes when you go and buy, for example, a storage device, you will find it 64 gigs or 32 gigs, 16 gigs. So the question is, why these numbers? So that's why. Now when we have also 1024 kilobyte, we will have what we know it as megabyte after that, and it will always remain in 1024. So after megabyte we have gigabyte, then terabyte, then petabyte, extra byte, and zettabyte. Okay, that's so simple in terms of why we have 16 or 32 in terms of storage or memory, and what the meaning of a binary language, so quickly going through it. Let's go back to our chapter. Program, which is the execute or run, which we input, an input will be accepted and some processing will occur and a result will be an output. This is the process of a computer. A program going to help us to deal with, for example, if we have word processing right this moment, we are using the keyboard to input data, and this data going to be processed to have it viewed online or on the screen that we have it. Program with syntax error cannot be executed. So when you will write a program and you run it or compile it, or try to execute it, it will not work. It will not remain. It will give you an error message. It will just not execute. Okay, we have what we call it a logical errors, which is errors in a program logic produce incorrect in output. For example, you want to do a calculation and the calculation is counting, for example, you want to count a 7%. Here we have in Florida 7% tax. You bought something for $100 and you want to calculate the taxes for it, but in the program you want to have the total. Now if you write in the program you said the subtotal, which is the 100, then you multiply it by 0.07, which is the 7%. When you put in equal, technically you will have just the tax amount. Okay, rather adding 100% the subtotal to the tax, then you have a total. You can simply do the the subtotal multiplied by 1.07, then you have the total immediately by having 107 immediately without going to have only the taxes. So that's what we call it a logical error. What the meaning of logic? A logic of a computer program, which is the sequence of a specific instruction in a specific order. This is so important to understand it. When you write a program, you need to write it in a logical way. It's a sequence. You cannot do, for example, a calculation of a total and you don't have yet an items in your calculation cart. For example, you cannot, because the answer will be incorrect. So you need to think in a logical way. You need to order stuff in a sequence to get it in order. We have what we call as a variable. What the meaning of a variable? Which is named memory location whose value and can vary. Now when we write a program, when we go ahead and write a program, we need to have a variable which maybe can be an input from us, and this input going to be changed whenever we have request. Okay, so what the meaning of a variable is: a storage place that in the memory that temporarily hold values to be used later on. Program developing cycle. It's so important to understand these steps. First, understand the problem, what you want to do by doing the program. Okay, when you have someone come, they will say, hey, we want to have a checkout program for our store. Now this is the problem: they want a checkout. They don't understand how you are going to create the program. They want the program. So you need to sit down and understand what they need. If you understand the problem, you can write the logic. Second step, you're going to plan the logic. Sit down, understand how you are going to divide it. Then you code the program. You use the software to compile or interpret it, to translate it into a machine language. Test the program. If it works, you put it into production. Then you keep maintaining the program. We will come to it in a few minutes. So, understanding the problem, then plan the logic, write the code, translate the code, test the program, put the program into production, and maintain the program. Understanding the problem, one of the most difficult aspects of a programming. You have your user or end users, which is the people who you are going to write the program for. Now, they don't need to know anything about how you are going to write it, what type of language that you are going to use, whether they don't need to know. They need to have the end product. So they will come and sit down and say, hey, we want such and such program. You need to understand everything they need, put it on a piece of paper, then go into the other part. Put it on a piece of paper, yes, you need to document everything. It's important to have something written down. So you need to have paperwork, supporting paperwork for the program. The requirement, the needs, everything need to be done through the paperwork documentation. Plan the logic. An algorithm is the sequence of steps or rules you follow to solve a problem. Most common planning tools will be the flowchart, the pseudocode, the IPO, which is input processing and output, the TOE, which is the task, object, and event. Then we have the disk checking, which is walking through a program logic on a paper before you actually write the program. The pseudocode. Back to the pseudocode. The pseudocode is one of the most important things. You are going to learn how to do flowchart, pseudocode in this course. Okay. Also, the algorithm is the sequence, the rules that you are going to write down. The program. If you have a pizza selection app, first you need to choose the pizza, then you choose the topping, the size of the pizza, then the type of the pizza, then the topping. So it's a sequence, it's an algorithm. Okay, you write it on a pseudocode, you write it in flowchart, and you work through to check it. The flowchart is so important because each shape going to refer to something. You are going to use visual logic in this course, which all about flowcharts. You're not going to technically write the pseudocode, however you need to write it on a piece of paper as you do your assignment. Then you go to the visual logic and you implement the pseudocode into a flowchart. Then you run it to check it through visual logic. Now, coding the program. Hundreds of programming languages available, which is a lot. You need to choose the base on features, what your capability, right this moment. If you go in programming and you ask, oh, your friend, he's a programming, and come, hey, can you program such and such program? He will say, no, I cannot use it because this is a different language that I don't know. Do I know all languages? No, I don't. I don't know how to, write a program in Java. However, I can use another program or another language to write my program. But similar in their basic capabilities, yes. All of them have the same logic, kind of. Coding isn't easier than the planning step, because when you have everything on a piece of paper, you just put it on the programming language and you're done. That's it. Experienced programmers can successfully combine logic planning and programming code in one step, which they start typing because they know the logic by heart and they will write it, so they don't need to sit down and do the flowchart, then they do the pseudocode, or the pseudocode then the flowchart, test it, then they will do it in one setting, one step. Using software to translate the program into a machine language, translator or compiler or interpreter, which is a program going to take your instruction to be changed into zeros and ones that the computer can understand. Now, whenever you have a program right this moment, in order, whatever program language you are going to use, it needs to go into the computer as a binary. So we have translation. So change the program's English-like, which is high-level programming language, into a low-level machine language, which is 0 and 1. Syntax error, as we said, which is the misuse of a language's grammar rules. Programmer correct list syntax error and may need to be recompiled the code several times. If you are going to program, for example, using visual logic, and you test it and it didn't work, you are going to recompile only the steps that, process only the steps that has been changed, because technically the program do have the others in machine language. So technically it will highlight in green, that means do understand that's in the machine language, and the other, which is yellow, to be later on, just a line next to it. So this is how the the process is going to be of translating the program. Testing the program. Logical errors result when a syntactically correct statement but wrong one of the one for the current context is used. So we have error that do not stop the program, however the result is incorrect. So we need to ensure from the program. So we test it to make sure the program includes the correct results. Then we go ahead and test it, which is to execute the program with some same simple data to see whether the results are correctly or logically correct. Sorry. Welcome back. Debugging is the process of finding and correcting programs' errors. We call it a bug. If you saw before programming movies or whatever, we call it a bug, which is an error that we need to fix it. So the debugging is the process of finding and correcting program errors. Programs should be tested with many sets of data in order to ensure everything is correct. Putting the program into production after we process the developing of the program, writing the codes, process depends on program's purpose, may take several months in order to be developed, and the conversions, which is the entire set of action and an organization may take to switch over to use a new program or set of programs. Now we have a program in production, we need to put it down, and we have another program going in. This is the life cycle of a program, all of that. But when we have a program, we need to put it into a production. Then we need to keep maintaining the program, or the maintenance of a program, which is making changes after the program is put into production. We have minor changes and major changing. Common first program job, which is maintaining previously written programs. Then we have make changes to an existing program, which is repeat the developing cycle to ensure the program is up to date, don't have bugs, and fixing errors, and so on. This is the meaning of maintaining a program. Using pseudocode statements and flowcharts. Pseudocode is an English-like representation of a logic steps taking to solve a problem. Flowchart, which is pictures, maybe shapes that we can represent of a logic steps in taking to solve a problem. So one is the shapes, the other one is an English-like language. Writing a pseudocode, which is also, we said, representation of a number doubled problem. So this problem, we have the start and end. Any program, we need to have a start and end. This is pseudocode, so we need to write start. Then we say input my number, set my answer to be equal to my number, multiply by 2, output my number or my answer, and we are done with the program. Right this moment we have an input. We are going to input something. My number right this moment consider a variable. The first thing in the chapter was talking about variables. My number right this moment is a variable. We will have a question, or in the CMD, which is the command prompt, we will have a way to accept data. So we are going to put 2. The moment that we have 2, for example, will be multiplied by 2, and we get my answers to be displayed. And this is also more information about pseudocode. Drawing flowchart. Create a flowchart, which is draw geometric shapes that containing the individual statement. Connects shapes with an errors like this one. Input symbols, which is this one in front of you, indicates input operation. Then the processing symbol, which is containing processing statements such as arithmetic, which is rectangle. Then we have the output symbol, which is also representing an output statement. Then the lines, which is the errors that as we saw. Then the terminal symbol, which is the start and stop of the program. Just like this, the program that we use pseudocode to double the number, my number, in front of you is a pseudocode, and in front of you is the flow chart. Repeating instruction, which is program in figure 1, only works for one number, not feasible to run the program over and over 10,000 times. Not feasible to add 1,000 lines to code program, so we can create what we call it a loop, which is repeating of a series of steps instead of avoiding an infinite loop. We need to ensure that the program ends. Infinite loop, that means the program not going to end, like a virus will keep running. If you create a program that don't have an end to the loop, we will have infinite loop. Okay, so technically this is incorrect because we need to keep repeating our program. So what we can do, which you can see do not do, okay, because we'll keep going on. So we have what we call it a making a decision, which is the centile value to end a program. Now testing a value, my number equal to 0, yes or no. If it's yes, then you go. If no, you will take another action, which is the decision symbol, which is the diamond shape. Dummy value, which is data entry value that the user will never need, which is the centile value. End of file, which is marker at the end of the file that automatically acts as a centile, which is to end a program. Right this moment, we have do not use, which is steps that we cannot use it because it's incorrect. Understanding programming and user environment. Understanding program environment, which is we have a text editor which is used to create simple text files. Integrate development environment, IDE, which is to provide an editor, compiler, and a programming tools like Microsoft Visual Studio, IDE. Understanding user environment, we have the combine or the command line, which is a location on your computer screen that at which you type the text and then it will appear, entries will to communicate with the program. Graphic user interface, or what we know it as GUI, which is allow users to interact with the programs in a graphical environment. This front of you is Visual Logic or Visual, sorry, not Logic, Visual Basic. Here is what we have, the CMD or the command line environment. You have a black screen, white texting, and you interact with the program. Here is the GUI, which is a graphic user environment or interface that you can interact with the program same as this way. And is that understanding the evaluation of a program modules. People have been writing programs or modeling programs since 1940s. Newer program languages appearing. Before we had C language, then C++, then Java, then different languages appearing every day. Look much more like natural languages, easier to use, create self-containing modules or program segments that can be pieced or together in a variety of ways. We have ready-made module that you just pull it in, right? For example, a login, process, multiple things. Major modules used by programmers, we have the procedural program and object-oriented programming. Procedural programming focus on the procedures that the program create. The objective-oriented program focus on the object or things and describe their features or attributes and their behaviors. We will learn more about procedural programming and objective programming in the upcoming days. This is the summary of the chapter. If you have any question, please post it on your